So let's continue our example in the design of members for shear. Okay, so nasa problem number 4 na tayo. So here, determine the available shear strength and adequacy of an ASTM A36 L127 by 76 by 6.4 with the long leg vertical with end shears of 15 kN from dead load and 45 kN from the live load. Okay, yung section naman natin ngayon is an equal angle with the long leg daw as vertical. So yung magiging orientation ng beam natin for this one is ganito. So yung long leg vertical, ibig sabihin yung 127 yung nakatayo. This is 127 and this is 76. So ganyan yung orientation ng beam natin. So the end shear is 15 kN for the dead load and 45 kN naman from the live load. So binigay na niya yung shear. So ang gagawin lang natin dito is to identify the required shear strength by the given loading. Okay, required shear strength. Okay, so we have for LRFD, VU, ultimate. So we have 1.2 of dead load plus 1.6 of the live load. So we have 1.2 of 15 plus 1.6 of 45. Therefore, we have 90 kilonewton. Okay. And then for ASD, we have VD plus VL. So 15 plus 45. Therefore, we have 60 kilonewton for ASD. Okay. So after that, determine na natin yung geometric properties of our section. So for the geometric properties, open your AISC and look for the geometric properties of the given section. Okay, so nilista ko na din kanina. We have a depth of 127 millimeters, the width of 76.2 millimeters, thickness of the web 6.35, and then of course para sila ng thickness of the flange, that is also 6.35, and then H is equal to, okay, so for our angle guys, yung H dito is just equal to our depth. So kung pupunta kayo sa AISC nyo, proceed kayo dun sa unequal angle, wala tayong makikitang value for H because the H is just equal to our depth. Okay, ayan. For example, ito, unequal angle, wala tayong makikitang H. Ayan. So it will just pertain to the depth. Okay. Depth is equal to H. Therefore, we have 127 also. 127 millimeter. So having the geometric properties, or after having the geometric properties, check na natin if transverse stiffeners are needed. So check if transverse stiffeners are needed. Okay. So proceed na tayo dito sa NSCP 507.2.2 and then check natin if this equation will be satisfied para malaman natin if transverse stiffeners are needed or not. So we have H all over TW. Is it lesser than 2.46 square root of E all over Fy? So yung ating H is equal to the depth, which is 127 millimeter, divided by 6.35 is equal to 2.46 square root of 200,000 divided by 250. Sorry. Is it lesser than? Yan. So, yung HL over TW natin is equal to 20. And, okay, it is lesser than 69.58. Okay, so not satisfied, therefore, transverse stiffeners are not needed. Okay, transverse stiffeners are not needed. Okay, so since wala tayong transverse stiffeners, the tension field action is not permitted. Okay, also, tension field action is not permitted. Okay. Okay, so let's continue. Okay. Since wala tayong transverse stiffeners and tension field action is not permitted, we can now proceed to the computation of the nominal shear strength. Okay. Later on, I will be providing problems that requires transverse stiffeners na. So, nagkakataon lang na yung mga nauna nating examples doesn't require transverse stiffeners, and also the tension field action is not permitted. Okay. So, nominal shear strength. Okay. So, yung ating section is a single angle, unequal angle, no? Therefore, maghahanap ngayon tayo dito sa NSCP ng para sa section that is exclusively for angle. Okay, so check natin. 507.2 are for singly and doubly symmetric members. Next, 507.3, that is for field tension or tension field action. 507.4, yan. Meron tayo dito for single angle. Meron din for rectangular HSS, for round HSS, and for the weak axis shear in singly and doubly symmetric shapes. And of course, for beams and girders with web openings. So basically, yung ating shape is a leg or an angle with an unequal leg. Therefore, we can use 507.4, single angle, on which the nominal shear strength VN daw is equal to 507.2-1. So, yung computation natin for the nominal shear strength is based on 507.2-1. So, VN, okay, sit tayo sa 507.4, single angle. Okay, so the VN is equal to, according to 507.2-1, 0.6 Fy AW of CV. Okay, next. Where CV is equal to 1.0 and AW is equal to BT, in which the CV is equal to 1.0 and then AW daw, or the area of the web, is equal to BT. Okay, kung mapapansin nyo, nag-iba na tayo ng formula for the area of the web, on which B is the width of the leg resisting the shear force. Width of the leg resisting the shear force. Okay, so ito yung section natin. Yung higher or yung longer leg, siya yung naka-vertical. Ito naman yung 76.2. Okay, based on this illustration, ito yung magiging web natin. This is the web. And again, as I have said a while ago, yung web natin will resist the shear. Therefore, ito yung area na to, yung magre-resist sa shear natin. Therefore, AW is equal to BT, on which the B is the width of the leg resisting the shear force, multiplied its thickness. So, ano ba yung width of the single angle that will resist the shear? It is the 127, kasi dito nga nag-a-act yung ating shear force. Ito yung nagre-resist sa shear force natin. So, B is equal to 127, multiplied its thickness, we have 6.35 thickness. Yes, 6.35. Okay. thickness is 6.35. Therefore, the area of the web is equal to 806.45 square millimeter. Okay. Okay. So, okay na tayo dyan. Therefore, Vn, or the nominal shear strength, is equal to 0.6 multiplied by 250 by 806.45 multiplied by 1.0 as our CV. Therefore, the nominal shear strength is equal to 120.97 kilonewton. Therefore, the available shear strength is now equal to, sa LRFD, meron tayong phi VVN. So again, nasa 507.4 na kasi tayo. Therefore, pwede na natin gamitin yung in-specify dito na 0.9 tsaka 1.67. Okay, so we have 0.9 multiplied by 120.97. Therefore, we have 108.87 kilonewton. And then for ASD, we have Vn divided by the safety factor, 120.97 divided by 1.67. Therefore, we have 72.44 kilonewton. And then comparing it with our required flexural strength, we have 90 tsaka 60. So obviously, they are greater. Yung available is greater than 90 kilonewton and then 60 kilonewton. Okay, so therefore, the shape or the section is adequate. Na kahit hindi natin lagyan ng tinatawag nating stiffener, kaya pa rin niyang i-support yung given loading natin. Okay? Madali lang yung design of shear. So, proceed na tayo sa number 5. So, determine the available shear strength for an ASTM A500 grade C, HSS 152.4 by 101.6 by 9.5, on which the long leg is vertical, with end shears of 50 kilonewton from dead load and 145 kilonewton from the live load. Okay. So, HSS naman, no? HSS. Tapos, nagbigay na din siya ng end shear of 50 kilonewton dead load tsaka 145 for the live load. Okay. So, dating gawe, we will first compute for the required flexural strength. Required shear strength. Okay, so for our required shear strength, unahin natin si LRFT. Okay, so we have 1.2 of the dead load plus 1.6 of the live load. Therefore, 1.2 of 50 plus 1.6 of 145. Okay, therefore, under LRFT, the shearing strength is equal to 292 kilonewton. And then for AST, just the dead load plus live load. So 50 plus 145. So we have 195 kilonewton. Okay, so these are when loading. Okay. So, proceed na tayo ngayon sa geometric properties. Open your AISC. And then proceed to the section. Okay, geometric properties. So, nilista ko na din kanina. We have a depth of 152 millimeters, width 102, thickness 9.53 millimeters. Thickness of the flange, we also have 9.53. And then H is equal to 126 millimeter. Okay. And then, after having the geometric properties, check na natin if kailangan ba ng transverse stiffeners or not. Okay, so by computing this one or by using section 507.2.2, transverse stiffeners, check if transverse stiffeners are needed. Okay. So 507.2.2, compare ulit natin tong formula na to. HL over TY or TW. HL over thickness of the web, is it lesser than 2.46 square root of E all over Fy? Okay, so direct substitution lang natin. H is equal to 126. Thickness of the web, 9.53. Therefore, we have 13.22. And then, is it lesser than 2.46 square root of E all over Fy with Fy is equal to 345. Okay, therefore, we have 59.23. Okay, so nasatisfy yung given scenario that HL over TW is lesser than 2.46 square root of E divided by Fy. Therefore, transverse stiffeners are not needed or not required. Transverse stiffeners are not required. Okay, and since wala tayong transverse stiffeners, wala ring mangyayaring tension field action. Also, tension field action is not permitted. Okay. Since nalaman na natin that transverse stiffeners are not needed, proceed na tayo ulit dun sa section 507 to determine the nominal shear strength. So, maghahanap ngayon tayo ng section that is exclusive for HSS. Kasi yun yung section natin ng 152.4. Parang rectangular yan. Parang rectangular HSS. Okay. So, hanap tayo. So, 507.4 kanina is channel. 507.5 rectangular HSS and box members round HSS. Okay. So, ang gagamitin natin dito is section 507.5 since our section is an HSS. So, that is considered as rectangular HSS. Therefore, use 507.5 in computing for the nominal shear strength. Okay, section 507.5. That is for rectangle or rectangular HSS. Okay, so basahin natin yung nasa 507.5. Rectangular HSS and box members. The nominal shear strength Bn of rectangular HSS and box members shall be determined using the provision of 507.2, on which AW or the area of the web is equal to twice HT, where H is the width for the width resisting the shear force, shall be taken as the clear distance between the flanges less than the inside corner radius. And if the corner radius is not known, H shall be taken as corresponding outside dimension minus 3 times the thickness. Okay. So, gamitin daw natin yung section 507.2.1 for the formula of the nominal shear strength, which is this one. Ayan. Vn is equal to 0.6. Sulat natin. Vn is equal to 0.6 Fy AW of CV. Okay. What is area of the web? AW is, shall be determined using the provisions of section 507.2-1 with AW is equal to 2HT. AW is equal to HT. Tama ba? 2HT pala. 2HT. 2HT on which H for the width resisting the shear force, shall be taken as the clear distance between the flanges plus the inside corner radius of each side. Okay, gets. So yung HSS natin, okay, let's say this one. So ano yung nagre-resist sa ating shearing force? Ang nagre-resist is the web. Dito yun. Okay. Therefore, H is the width resisting the shear force shall be taken as the clear distance between the flanges less the inside corner radius on each side. Okay. Clear distance. Ito daw, clear distance between the flanges less the inside corner radius. Ito kasi yung clear distance, di ba? Ito yung clear distance of between the two flanges minus the corner radius. So, yung ginagawa natin pag HSS, di ba? Meron yung mga fillet. Kasi, fillet sa loob, nagkakaroon ng parang radius or fillet radius. So, nandito yung H. Yan yung H natin. And according to AISC, H is just equal to T. Okay, so yan yung gagamitin natin. T. So, the area is equal to 2. Ano yung H natin? Given yan sa ating geometric properties, and that is 126 mm. So, 126 multiplied by the thickness, that is equal to 9.53. So, 9.53. Therefore, we have 2401.56 square millimeter. And then for CV, according to 507.5, we have shall be taken as the clear distance between the flanges, blah blah blah, and KB is equal to 5. Okay, so for the computation of our CV, we will use section 507.2.1 kasi yun yung provision na ginagamit natin. This one, 507.2-1. So here, for webs of all other doubly symmetric shapes and singly symmetric shapes and channels except round HSS, the web shear coefficient CV is determined as follow. So, yung formula natin for CV is provided here. Yan. Depende na lang kung ano yung section natin. So, yung section natin is an HSS. So, this formula is for sections of doubly and singly symmetric channels, tapos except around HSS. So, pasok kasi rectangular yung HSS natin. So, ang gagawin natin dito is to look kung ano yung nasatisfy dito sa mga equation. Kung ito ba, 1, 2, or 3. So, ang i-complete natin dito is the H all over TW, 1.1, tapos yung 1.37. Okay, so unahin natin si H all over TW. Na-compute na natin yan kanina, if I'm not mistaken. We have 13.22. Okay, next, 1.1 KVE FY. square root of KVE all over Fy. So, yung KV natin, according to section 507.5 is equal to 5. Yan, KV is equal to 5. So, we have 1.1 is square root of 5 of 200,000 divided by 250. Or, ano yung Fy natin? 345 pala. 345. Okay. 345. Therefore, this is equal to 59.22. Okay. So, H all over TW is lesser than 1.1 square root of KVE all over Fy. Therefore, CV is equal to, makikita naman natin, kahit hindi na natin i-solve yung 1.37 something, kasi nakikita naman natin that H all over TW is less than 1.1. So, nasatisfy na agad. Yan. Therefore, CV is equal to 1.0. Yan. So, time to substitute. Okay. Therefore, Vn is equal to 0.6 of 345 multiplied by 241.56 by 1.0. Ito na yun. Tinuloy ko na dito. So, Vn or the nominal shear strength is equal to 497.12 kilonewton. Therefore, the available shear strength is equal to sa LRFD. We have phi VVN. Yung phi natin is 0.9 of 497.12. So, we have 447.41 kilonewton. And then sa ASD, we have Vn divided by the omega. So, 497.12 divided by 1.67. So, this is equal to 297.68 kilonewton. Okay, so upon comparing it to the required, meron tayong 292 tsaka 195. So, greater than 292 kilonewton tapos 195. So, safe. Therefore, the section is adequate. Okay.